Hi gang, I'm going to talk about how radiation works using Americium-241 as an example. Inside this housing is a small round silver-colored object containing Americium-241, a radioactive material. This whole thing came from an ionizing type smoke detector, like this one. It was mounted behind this metal box, the one labeled radioactive material. The Americium-241 is radioactive because it's unstable. It's slowly changing into something else, and it does that by giving off pieces of itself in the form of alpha particles. As a byproduct, gamma rays are also given off. This giving off of alpha particles and gamma rays are the radiation that's going on. They're being radiated away by the decay of the Americium-241. Let's look at it more closely. Here's the nucleus of the Americium-241 atom. It has 95 protons and 146 neutrons. 95 plus 146 equals 241, hence Americium-241. But it's the number of protons, the 95, that makes it an americium atom. The alpha particle that it emits when it undergoes radioactive decay is really 2 of those protons and 2 of those neutrons. The result is something that has only 93 protons and 144 neutrons. Since it now has 93 protons instead of 95, it's no longer an americium atom. It's now a neptunium atom instead. Neptunium-237 to be precise. In the periodic table of elements, it's moved from here to here. What about the gamma ray byproduct I mentioned? Once the americium has decayed into neptunium, the neptunium is in an excited state. It then moves to a lower energy state, emitting a gamma ray at the same time. Those gamma rays are electromagnetic waves, just like light, but have a much higher frequency and a much shorter wavelength. Here's a setup that can be used to detect these alpha particles. I've got my homemade high voltage power supply, a variac so I can adjust the voltage, and I've arranged a small spark gap here. If I turn the voltage up high enough, you can see it arcing across the gap. Now I'll turn the voltage down, just below what's needed for arcing. The reason the arcing stopped was because air is normally an electrical insulator. It doesn't conduct electricity. Each atom in that air has the same number of protons as electrons. They're not charged or electrically neutral. Next, I've attached the americium, still in its housing, to the end of this long plastic stick. That's so I don't get shocked during the test. For the test, I bring the americium close to the spark gap, with nothing between it and the spark gap. You can see that when I do that, arcing happens. Alpha particles, consisting of 2 protons and 2 neutrons, are pretty massive, and so they don't get very far before they collide with other atoms. And given the energy of those alpha particles, they knock electrons from those atoms, causing those atoms to be positively charged. What are called ions. That means the air is now more electrically conductive. And since the air is more electrically conductive, the electricity can cross from one side of the spark gap to the other, in the form of an arc. We call this type of radiation ionizing radiation, since it results in the creation of ions. How dangerous is this radiation from Americium-241? You saw that the alpha particles don't get very far in air before colliding with other particles, only a few centimeters. It's often said that the alpha particles can be blocked by a piece of paper, but here it is up close with 5 pieces of photocopier paper and a few are still getting through. The same is true with a piece of cardboard. However, a thin piece of plastic cut from a margarine container seems to block them completely, and so does this thicker piece of plastic from a hobby store. Swallowing or inhaling it can result in cancer, so wear gloves when working with this stuff, and preferably don't remove it from this housing. At least if it's still in the housing, then there's no danger of swallowing it or it breaking up into smaller pieces. What about the gamma rays? Since those gamma rays are high-frequency electromagnetic waves, they can't be blocked by paper, or even the parts of your smoke alarm. However, the gamma rays emitted in this case by neptunium have low energies. Not all the Americium-241 atoms in this pellet are changing into Neptunium-237 at the same time. It has a half-life of 432.2 years. That means that after 432.2 years, half of them will have changed. Then, in another 432.2 years, half the remaining Americium-241 will have changed. And half again in the next 432.2 years, and so on. So as time goes on, less and less will be changing, and less radiation will be happening. Well, thanks for watching. Check out my YouTube channel, rimstar.org, for more videos like this. That includes one on how nuclear fusion works in the sun, another on how rockets work to get from the Earth to space, and another on how crystal radios work. And don't forget to subscribe if you like these videos, or give a thumbs up, or leave a question or comment below. See you soon!